Hi everyone. So today we discuss a case study. The case study is all about the bike shares rides. So this presentation explore bike share data to reveal user behavior, trends and opportunities. We analyze ride IDs, bike types, timestamps, station data, geolocation and rider categories to provide insight into program usage and growth potential. So the objective is to analyze ride-sharing data, extract actionable insights regarding usage trends, ride types, and station activity, ultimately supporting business strategy and customer segment. So, what the dataset is all about? So, in our dataset, we have some specific column. So, the first one is the ride ID, which tells the unique identifier of each ride. Rideable type, that means what type of bike they use. So, in our dataset, they use dog bikes. Start station name and end name, the station name and end name. Member casual in the means that what type of rider use like a member or a casual. The start geolocations, the start timestamp and end timestamp for each ride start and end. So the case in this case study, the questions are arises like this: how do members and casual rider differ in duration? What are the peak hours for usage? What day sees the highest traffic? Which stations are most used for starting or ending rides? Which rideable types are most preferred? Which station have the highest demand during peak hours? What is the average number of rides per day, week, and month? Is there growth or decline? So before that we analyze the visualization, first of all we go in the Jupyter notebook and do the data preprocessing. So let's switch in our Google Colab notebook here. So what we have to do, first of all, we import our data set in a Python. After that we check is there a column in which null values is present. So we find there is some columns in which null values present, like end station name, end station ID, end let, end length. So there is no use of column like end leg or end length geolocation. So we will drop. I will show you how we will drop it. So first of all, what we have to do in the end station name column, we fill NA with a particular value unknown location. The next thing is an end station ID. We similarly fill the NA value via the unknown ID. Then we drop the columns like end let and end length, the geolocation. There is no use in this case study. After that, what we have to do, we convert all columns in the lower case. Next thing, what we have to do, we convert the datetime format. Like in the started at timestamp, we convert the format of datetime into YMD form. Similarly, we do that for the end time location. Then we calculate a new column. I call the column name ride duration. In the ride duration, what I have to do, I subtract two columns, ended at time step, subtracted and started at. And I extract from that the time which I got a total seconds. For that I divided by 60. From the column started end, I extract the date column. The and that column I call the date. Similarly, from a started at column, I extracted column month and the column I give the name month. Similarly, I extract hour from started at column and from the started at I extract the week name. For that I call the column day of a week. So this is all about the data pre-processing. Let's go with our presentations and discuss the visualization questions. The first question is, how do member and casual rider differ in trip duration? For that, I plot a box plot. The box plot is all about the member tab. In the member tab, I have two categories, member or casual. On the y-axis, I plot a minute. So, from this visualization, what insight I found, casual user tend take longer ride than a member. Casual ride might have longer trip, especially on weekend or during the leisure activities. Then the next question what I have to do, what are the peak hours for usage? For the peak hours, I plot a histoplot plot in Python using a Seaborn library. So from the histoplot, plot, I find the member ride have peak during commute hour, for example, 7 to 9 hours and 5 to 7 pm. Casual ride may have a more spread out usage or peak in the afternoon in weekend, as you see in this visualization. So the next question is, what days see the highest traffic? For that, I plot a bar plot. From this, what I have found, weekend might show higher traffic for casual riders. The blue legend show a member and orange legend show a casual. Weekdays will likely show more consistent user for members. Then I plot what the top 10 stations according to ride count. So the top 10 stations are following as. Similarly, top 10 end stations I make a plot using a Python. So the 10 end stations are as follows. So the most popular bike rideable type is dog bike. I have only one category of bike that's called a dog bike, which have a number of rides are 80,000. Then we plot the high demanding hubs that may need more bike or dogs. So the top 10 stations during peak hours, I plot a count. Suppose Clark ST and ELM ST have a count to 96. For that, I plot a bar plot. Then we plot a line chart for the according to the date with the rides. Suppose in 2020 month 4 on date 1 the number of rides is approx more than 2000. On the date 5 the rides goes on approx more than 5000. As the time pass the rides will go down, but at the 25th month of April it's go very high poke on the 6000. Similarly, I plot for a land plot according to the weeks. So in April, the ride count is approx 20,000, and in the 13th date for the fourth month of month, the ride goes some peak down similarly some 16,000, and in the 27th date in the April month it goes some around the 12,000. For again, I plot a monthly ride count for a fourth month, that is April. The ride count is goes on 80,000, which I show earlier in the previous slide. So what the conclusion we found from this analysis? First of all, the trip duration. Casual user typically take longer rides compared to member, suggesting they use service more for leisure or tourism, while member use it for commuting or short distance travel. What insight we found from peak users, however, members ride during weekend peak hour like 7 to 9 am or 4 to 6 pm, aligned with work commute pattern. Casual riders are more active on weekend and afternoon. The day of week trend we find the weekends, especially Saturday, see the highest traffic from the casual user, while member activity is more consistent through the work week. From the daily, weekly, and monthly rides, there is a noticeable seasonality in the data, with ridership peaking in the warm months. Every ride volume increase over weekends, so a gradual monthly growth indicated increasing adoption. The growth analysis we find the monthly trend suggests an overall upward trajectory in usage driven largely by casual rider during peak tourism seasons and member during commuting months. So this is all about the case study about the bike riders. What is the hours peak? What the ride count according to weekly, monthly, and daily? Thank you.